Hi, we're Team 53. We're doing verification of analog circuits. The goals of our project is to design a small secondary footprint circuit that can detect accidental malicious additions and modifications to the circuit during manufacturing. The second main goal is to develop, design, and test methods to bypass the aforementioned authentication circuit. And the last goal is to use neural networks and machine learning to help with the authentication of the circuits and do it automatically.
All right, and then my name is Andrew, and I'm one of our circuit designers here. And you can see that we have, so far there's two. We have the older one on the left for your reference, and this is just one of the first initial voltage controlled oscillators that we came up with in the bottom right, you can kind of see we implemented the Colpitts tank oscillator. And then on the right, you can see we have the new circuit that we've been working on. And this one is just a CMOS LC VCO. So the center is what would be the like brains of this oscillator. And you have both PMOS and NMOSs stacked on top of each other. And from this one, we would like to kind of look at the peak frequency and or sorry, not the peak frequency, the peak voltages and frequency, and see how those are impacted by um, different changes. And then we hope to plan on getting at least two other circuits, hopefully an LDO and possibly an LNA circuit.
Hi, my name is Samantha, and one of our plans as attack is coming up with possible ways the circuit can be created with errors that are unintentional. So this can be like changing the values on the different components in the circuit so they are out of tolerance, and we're going to see how this affects the output of the VCO. One example of this is changing the resistor that is connected to the drain of an NMOS, which then controls the circuit of the current that goes through from the drain to the source of the NMOS, and that can affect the output of the circuit.
My name is Nicholas. I'm also working on the methods of attack for the circuit. And one way that the circuit can be harmed is if a manufacturer implements Trojans to maliciously damage the circuit. So the objective here would be to actually break the circuit and render it unusable. In the case of a voltage controlled oscillator, that would be creating a frequency that has too high of a magnitude or too high of a frequency that can cause the different components in the latches to not be in sync or to cause a bad frequency that would not be able to transmit signals. So by doing this, we would be adding additional components to the circuit in hopes to later on authenticate it and catch those changes. And when a voltage is input or a signal is sent to the circuit, then it'll cause the oscillator to report values that are outside of what's needed.
Hi, my name is Josh. I'm working on the methods of verification to detect any accidental or Trojan-based changes in the circuits. The main things we're going to be looking at is going to be the power draw. That will detect if anyone has changed the power draw of the MOSFETs themselves, or even if they added like some sort of sub-circuit or added additional components, that could also affect the amount of power that's drawn. And then because this is an oscillator, a big thing we're going to be looking at is doing frequency domain analysis. And that way we can make sure that everything's operating at the correct frequencies. And then along with that, we're also going to be looking up the startup and power off characteristics. So that's like as the voltage level is rising going to it, to see if it turns on and off gracefully, and doesn't cause any disturbances down the line for the components attached to it. Furthermore, we're also going to be looking at the output characteristics. So that will be stuff like the voltage swing range, so how the maximum voltage that comes out of it, as well as the rise and fall times, making sure it's able to actually change quick enough to trigger the other components that we hooked up to it for, like, say this was a clock. And then finally, one way we've been thinking about doing this on top of just statistical analysis is just implementing a neural network that we could feed the inputs into and train it based on our reference device. And then that way, when a device is actually produced, we can plug it in and have the neural network decide whether or not this has been tampered with. And so that is our project so far.